Hey everybody, I'm back with experiment number 2. This experiment has to do with chemical reactions. What happens when you combine two chemicals? Sometimes nothing, sometimes a little something, sometimes a big something. It all depends on how those two substances combine and if they create a new substance out of that. This experiment combines a couple of different things to definitely create something new, and there is a real reaction when it happens. To start this experiment, you're going to need a couple of things. You're going to need a plastic bottle, like this one, something you don't mind throwing away. You're going to need a bowl or a big tub to hold it in, because you don't want to make a big mess. That's a hint. I have a glass container here, sort of to stabilize my bottle, because my bottle is a little bit wobbly. But that's not necessary if you have a bottle that's not very wobbly. So on to the chemistry part. There's a couple of things we're going to need. We're going to need, and this is the one special thing, this is hydrogen peroxide, but it's not the normal hydrogen peroxide you get if you go to the grocery store or the pharmacy. This is a different kind of hydrogen peroxide that you can find in a beauty supply store. It's usually called volume 20 or developer or activator, and it's pretty much like the hydrogen peroxide that you can get in the store at the pharmacy that you use in a cut or something like that. But instead of being 3% hydrogen peroxide, this is 6% hydrogen peroxide, so it's twice as strong. You can also get volume 30 or 40, which produces a stronger reaction. But for now, we're just going to use this one. You're also going to need some yeast. A single packet of yeast is fine. If you're not using packets, you're looking at about 2-3 tablespoons of yeast. You're going to need half a cup of the volume 20 peroxide, and you're going to need a couple tablespoons of dishwashing detergent and a little bit of food coloring. You don't have to have the food coloring, but it makes it a lot more fun. All right, let's start. The first thing we're going to do, and again, important to have an adult to help you, because hydrogen peroxide, especially the strong kind like this, can damage clothes, it can irritate your skin, terrible for your eyes. Really need to be careful with it. So I'm going to use a funnel to help me get the hydrogen peroxide into the bottle without spilling anything. Half a cup of hydrogen peroxide into the bottle. All right? Now, going to add food coloring. 8 drops should be enough. Doesn't have to be green. I'm doing it green for the holiday season. 1, 2, 3, 4, 5, 6, 7, 8. All right? Now, I'm going to take the dishwashing soap. It's just plain old dish soap. And for this, about a tablespoon. Some chemical reactions require a very specific amount of each ingredient. But here, if you're a little bit over or a little bit under, it's not going to change the fact that something's going to happen. It might just change how fast or how strong a reaction we get, but we're still going to have a reaction. There's a tablespoon of the dish soap. All right? This is all we need for in the bottle right now. Let's see, we have the peroxide, dish soap, and the food coloring, just to give it a little color. I'm going to swirl it around now. Nothing's reacting yet because the dish soap and the peroxide and the food coloring don't really have any reaction with each other. So we're not creating a new chemical here. All we're creating is a mixture, a mix of 3 different chemicals. But no reaction is happening here. How do we know? Well, it's not changing in any significant way. It's not getting hotter, it's not getting colder, it's not expanding, it's not contracting. There's not a color change that we can't account for just from the food coloring. Nothing's really happening. It's just mixing up. So this is not a chemical reaction. This is just a mixture. All right. Now that we got that ready, we need the second part. This is dry yeast. Open it up and put it in 3 tablespoons of warm water. We're going to let that sit for about 30 seconds. Okay, folks. We've given our 2 to 3 teaspoons of yeast time to get warmed up in about 3 tablespoons of water. Now they're mixed up and ready to go. I'm going to give it one more quick swirl. Make sure we got a nice slurry going on here. All right, so here's the bottle. Remember, we've got peroxide, food coloring, a little bit of dish soap. I'm going to put the funnel back in so we can do this quickly. And then we're going to step back. Everybody ready? Here we go. Now we can clearly see there's been a chemical reaction. We have a big change in the structure. It's still going of the chemicals we started with. And you can't feel this because it's just a video, but the bottle is warm to the touch. That's called an exothermic reaction. Exo means out and thermic means heat. It gives out heat. There's also endothermic reactions. Endo means in heat. And those, instead of giving out heat, pull heat out of the air, and they actually feel cold to the touch when you feel whatever has had that reaction. As you can see, we've made a lot of foam here. The foam is produced by the dish soap, the green color produced by the green food coloring. What happened? Well, you have to know a little bit about the chemistry of the things that we used. Hydrogen peroxide has a chemical formula of H2O2. It might be familiar to you, but a little bit different. You've probably heard the chemical formula for water. It's 2 hydrogens, 1 oxygen. Hydrogen peroxide has an additional oxygen, H2O2. When I added the yeast to the hydrogen peroxide, the yeast quickly pulled away the extra oxygen off of that hydrogen peroxide, transforming it into water and oxygen gas. This has produced a lot of oxygen gas. But because there was soap, that gas was trapped inside the soap bubbles, producing foam. Lots and lots of foam. These little bubbles are all full of oxygen. And what's left now, instead of hydrogen peroxide, is just water and soap and some extra oxygen, which we can all breathe. No longer dangerous. A dangerous chemical now turns into a safe chemical. Still wouldn't drink it though. Anyway, have fun with this experiment.